In the last learning target, we learned how to simplify radicals with different values. Today's learning target, we're going to talk about simplifying radicals with variables and different exponents. So we're going to use some prior knowledge of exponents and what we know about square roots to fill in this table. So let's take a look at the first radical expression we have here, square root of x squared. The square root of x squared is the same thing as saying the square root of x times x, and to simplify that, we can just say x. In other words, if we have something like the square, let me get the pen working here. If we have something like the square root of 4, I know that's the square root of 2 times 2, so now I know that that has to just be 2. That's what this first table is saying, except we're saying that, okay, let's just pretend it's any number, not just 4. The principle has to stay the same, okay? So what happens if we have an odd exponent? Well, the factors become the square root of x times x times x. Well, that's the same thing as saying the square root of x times another square root of x. Well, what we just learned from the other table is that this square root of x times x simplifies to x, so this guy must simplify to x and then leave us with that other little square root of x next to it. Okay? Square root of x to the fourth, that's going to have 4 x's, so we're going to have the square root of x times x times x times x. That's just going to be the square root of x times the square root of x times x, which is really just x squared, because this is an x and this is an x. Now I know this sounds really confusing. We're going to keep filling in this table, and hopefully you're going to see a pattern here in a second, okay? I know that this looks still a little crazy. Square root of x to the fifth is 5 x's, which breaks into 2 of these times 2 of that plus 1 left over, which gives us x squared plus 1 left over. In fact, I have an idea here. I'm going to rewrite these in all one color, because I think that'll help us see the pattern a little bit easier. This is x squared square root of x. This is x squared. This is square root of x. Okay. The next one is x to the sixth. That's 6 x's, which breaks into an x, and an x to give us x to the third. Now, if we want to stop for a second and think about our evens and our odds, okay? So if I look at my even terms and my odd terms, so this is an even, right? X squared, x to the fourth, x to the sixth. Notice that x squared, the square root of x squared is x. The square root of x to the fourth is x squared. The square root of x to the sixth is x to the third. What is happening between this number and this number? Between this number and this number. And that one and this little invisible one right here. What's it doing? It's cutting it in half every time. Okay, so if I want to think about a pattern for my even exponents, for even exponents, we are dividing the exponent by 2, and then removing the radical. So for example, in this x to the 8th I have right here, there's the 8. If I do 8 divided by 2, that's going to leave me 4, so then my answer is going to be x to the 4th, and I remove the radical. Okay, it's that simple. So the square root of x to the 8th is x to the 4th. Now, odd exponents are a little bit different, and if we look at our table, you can see why. If you look at the table, my odd exponent, I had this square root of 3, and then I ended up getting this square root of x. Square root of 5, and then I get x squared square root of x. X to the 7th, well, what would come next? Well, it seems to me that I always have this guy hanging out, okay? And then in front of it, I have a term. So for an odd exponent, what you need to do is we're going to take the number that it's under there. So for example, this is x to the 7th. We're going to take the 7th and we're going to subtract 1. So 7 minus 1 gives me 6. When I take away that 1, he goes in the house. Okay, so one of them's away. I'm left with x to the 6th now, and then now I treat it just like an even exponent. I do that 6 divided by 2, I get 3, so I end up having x to the third in front of it. Okay, so for my odd exponents, you take away 1, take 1 away, it goes in the radical, and then divide by 2. And then then you get on the outside, okay? So with this pattern, how could you simplify something crazy like the square root of y to the 225? Well, I know that's an odd exponent, so I know that I'm gonna have to take 1 away. So I'm gonna take 1 away and I'm gonna put them in the house. If I take 1 away and put them in the house, I'm left with then not y to the 225, but I'm left with y to the 224. So I gotta then take that, do 224, divide it by 2. That's gonna give me 112. So that is my new exponent on my one that goes outside. So I took 1 away from 225, I put it in the house. With what was left over, I divided it by 2 and made that my new exponent on the one outside. Okay? It is a process to memorize. When you have odd exponents, a process to memorize when you have even exponents, when you're taking them in and out of the house. I think of it like a house. It helps me keep track of the rule a little bit easier. Let's do a few more examples. So y to the third, that's an odd exponent, so I'm going to take 1 away, and I'm going to put it in the house. So there's 1 gone. I've got 2 left over. Let me make that symbol a little bit easier. I've got 2 left over, so 2 divided by 2 cut in half gives me 1. So I'm left with y to the 1 outside. Okay. Number 2, that is an even exponent, so all I have to do here is do 28 divided by 2 to get 14, and my answer is m to the 14th. Take away the house. When you have even exponents, you can take away the house. It's gone completely. This is an odd exponent. I'm going to take away 1, put that r under there. That leaves me with 502. I've got to divide that by 2. I don't know what that is out of the top of my head, so I'm going to my trusty calculator here. 502 divided by 2. Oops. 251. So my new exponent, this is going to be r to the 251, square root r. Okay. This next one has 2 variables, but don't let that trip you up. Just do them one at a time. So the first one is x to the 4th. So you're basically looking at it like this. The square root of x to the 4th, the square root of y to the 5th. Treat each of them separately. So the x to the 4th, that one, if I'm just looking at that by itself, that guy just turns into x squared, right? Because we just take away half, take away the house. The y to the 5th, we have to take 1 away and put it in the house. So there's my 1 away, putting it in the house. I'm left with y to the 4th under there, so that would make it just be y squared. So then you bump them up next to each other for your final answer. So you do them separate, and then push them up next to each other for your final answer. Number 5, I've got m to the 6th n. Well, m to the 6th, it's like saying square root of m to the 6th times the square root of n. I can't do anything with the square root of n, so I'm just going to bring him down. But square root of m to the 6th turns into m to the 3rd. Divide that exponent by 2, take away the house. Number 6 makes it a little trickier, but by adding 1 more to each of them. So it's like saying, okay, the square root of x to the 9th, square root of y squared, and the square root of z to the 11th. Do one at a time. X to the 9th. Okay, now this one is a little tricky. I want you to think of this in terms of, okay, I've got one house. I've got one big house that all 3 of these guys share. For x to the 9th, I take 1 away from there and go in the house because that's an odd exponent. I'm left with 8 of them. Cut that in half, I get x to the 4th on the outside. That takes care of my x to the 9th. Go away. Square root of y squared, that's a nice even exponent. That just turns into a y. And he's gone. And then z to the 11th, we're going to take a z away and put him in the same house as x. That leaves me with a square root of z to the 10th, which just becomes z to the 5th. Okay, now ideally in a perfect world, I'd like these to be in alphabetical order, but honestly, as long as you have the right letters on the outside of the house and the right letters on the inside of the house with the right exponents, then we're fine. I don't need it to be in alphabetical order for it to be perfect. I just need to know which ones go in the house and which ones go outside the house. Same thing for number 7. I'm going to make a house. R, none of them go in the house. That's an even exponent, so I just divide 32 by 2. 32 divided by 2 is 16, so I get r to the 16th. So the r term is done. S to the 12th, that's also an even exponent. I just divide that by 2 and get s to the 6th. That one's done. T to the 45, though, I've got to take one away and put it in the house. Then I'm left with 44 of them, half of which would be 22. So there's my answer for number 7. And number 8, that A and that B, I can't do anything with them. The A and the B stay in the house. They're as simple as they can go. They don't have any other exponents on them. But the C to the 23, I'm going to take one away from that 23. That leaves me with 22 C's, which puts me at half of 11 on the outside. Okay, now this is a weird learning target. It's very abstract. It's very hard to wrap your mind around. So take your time on it. When you do the practice, you're going to get ones that have like a number in it. Like say you've got something like 12a to the 3rd. And on your practice, all that changes here is that, remember how you had to reduce these radicals to like square root of 4 times the square root of 3? So you're just doing that process. So this becomes 2 square root 3. Then when you go to do your letter, so you start putting everything under the house and outside the house it needs to go. So I've broken up the 4 and the 3. I've turned that into a 2 square root 3. Now I'm going to deal with my A. That's an A to the 3rd power. So I take one away, put it in the house. I'm left with a squared, which puts me with an A here. And then I got to put the 2 in front and the 3 in there as well. So the 3 and the A go in here together, okay, which is kind of tricky. So stuff all goes in the house together or it all comes out of the house together. Okay, there's just an in the house, out of the house situation, okay? And you'll get a lot of practice with that. I think there are 18 practice problems. It doesn't sound like many, but you're going to need to take your time on them because they can be tricky, okay? Good luck.